Hello, everyone. I'm Cindy Snide, Marketing Director for Revolution Group, and I'll be your host today for our discussion on MRP and master scheduling. A few housekeeping items before we start the webinar. We will be recording the webinar, and it will be available on our website at www.revolutiongroup.com, but I will also email you a link to the recording as soon as I get that put out there on the website within the next couple of days. We have allotted about an hour for this webinar, but we should really only run about 30 minutes, and at the end we will answer your questions. So please feel free to submit your questions into the questions section on your screen at any time. For those of you who don't know us, Revolution Group is a Central Ohio-based technology solutions provider founded in 1995. Our mission is to help our customers leverage technology to improve their businesses. We have been deploying MRP, ERP, and SRP systems for manufacturing companies for over 20 years. We do system selections, full service implementations of NetSuite and Plex Manufacturing Cloud. We also will do optimizations and best practices training to teach inventory control and lean principles. Our other company divisions represent Salesforce services as well as managed IT services, where you lend your technology role to us instead of having to manage your own in-house IT staff. Our speaker today is Tom Titensor, one of the senior manufacturing consultants here at Revolution Group. He has over 25 years of comprehensive practical manufacturing, production, planning, supply chain, procurement, and system deployment experience. With that, I'll let Tom take it away. Thanks, Tom.
Thank you very much.
Make you the presenter, though.
Okay. Show my screen. Here we go.
Go.
All right. Just a little bit of background about myself and how we came to this presentation. As Cindy said, I've got a number of years experience, and specifically with maybe a dozen or more different ERP type systems, computer-based. But I also had an experience with a non-ERP master schedule MRP program that I wrote, that we used in one of the companies that I worked for. And that's where we're using this as a basis today. So we're going to be talking about master scheduling. We're going to talk about MRP, also known as material requirements planning. We're going to take a field trip, and we're going to see the spreadsheet that I used to do our planning in that company. We're going to talk about manufacturing parts and components and finished good parts, and we're going to have questions at the end. Let me get to the next slide process. There we go. So we're going to start talking about master scheduling. And master scheduling really is all about managing your requirements or your demand from your customers. So we want to talk about time-phased planning, and the components of that are we need to have gross requirements, which are from your customers. We need to be able to get that demand, and sometimes our customers just say, I want this many things, and they want them over the course of a year. But they don't give you a lot of information necessarily. Some do, but we need to be able to take what they give us and make sure that we can provide that based on our constraints in our company and still provide them the things that they need. And that would become what we would consider level loading our shop. And that really is all about managing the due dates so that we can manufacture the parts they need and deliver them when they want to have them at their customer's site. So, examples of getting gross requirements from your customers. Customer A might just say, you know, this year I think we're going to buy 1,200 widgets from you. That's a broad brush stroke, and that's sometimes all you get. Customer B says, well, I want 3,000 of your widgets this year. And then we get customer C, and he gives us a little more detail, and he says, well, I want 2,400 widgets, and I want you to give them to me in the second quarter. And then by the fourth quarter, I want another 600. So if we spread that out into a spreadsheet and looked at it, that's pretty lumpy demand. And that's not very helpful because we might have big layoffs and we might have, have to big overtime in certain times of the year. And that's not very efficient in our production. So at the smallest, we might be having 2,500 pieces in the month of June and nearly 5,000 pieces needed by the time the end of the year. So when we talk about leveling the load, we want to have smaller buckets. And this example talks about buckets of a month. So we still say, all right, customer, you want 1,200 widgets over the course of the year, but for our purpose, we're going to plan 100 widgets every month. And even if we have to store them for you, then we will always be able to give you your 1,200 by the end of the year. Customer B, we would then say we want to build 250 widgets every month. And for customer C, we have, again, more detail. So we can say for the first and second quarter, we're going to produce 400 widgets every month. And for the last quarter, quarter 3 and 4, we're going to build 100 widgets in those two, for a month for those 2 quarters. So if we spread that out in the spreadsheet, this is much more usable and practical because we might have approximately 750 consistently every month. And then the second half of the year, we have additional capacity that we could fill with another customer's order without having any disruption in our production process. So that's the idea, is we want to make this as smooth and useful to the production process as we can because it makes us more efficient. So rule number 1 is it's better to build early than to explain why you're late. And that might be the only rule you need to know. So let's go to MRP, which is the giant calculator. It needs some input data, and that data is requirements, which we just talked about, which is your customer demand or the master schedule if you've tried to level load your shop. You need to know what your inventory is currently, and then the replenishments are your purchase orders to bring in new material and also the jobs that will produce the sub-assemblies and finished good products. And then the results of that information, as it goes through this giant calculator, you need to get the output data, which becomes action reports of various kinds. So if we look at it in a sort of a graphic way, you've got being able to manage your stuff, you've got the requirements and the inventory and the replenishments, and they all get fed into the big black box of MRP, and out from that comes your action reports so that you'll be able to act appropriately, and the suggestions that it makes will be able to support your goals to have a smoothly running shop. So let's talk about the big 3, the requirements, inventory, and replenishments. So, big important process here is that your data is going to be good, but if it's wrong, it's a killer. So your requirements, sadly to say, will always be wrong because it's only somebody's best guess. So even if it's a forecast, your customer says, well, I think I'm going to want this many during this period of time. But reality is, when that time comes, he's going, I really need 10,000 more of those things. Or he might say, you know what, we don't need quite that many. Let's drop that down to another, drop it by 1,000 pieces. So again, forecasting and your master schedule generally are going to be wrong until the actual order comes through. Now, your inventory is a very important component of this process, and there are some standards that would need to be met in order for this MRP to calculate with any value. The first one is your inventory accuracy has to be at or above 70% to be of any real value. Yes, you can run MRP with inventory accuracy lower than that, but there's going to be a lot of second guessing and people won't trust the system to act on what it suggests. And there'll have to be a lot of investigation to say, ooh, do we really have that part? Is that the quantity really there? Or, gee, I think I just ordered those. Why doesn't the system tell me that? And so they go investigating and spending a lot of time finding out and verifying if the inventory is accurate or not. Now, you want to be able to target at 98% or higher, and again, it creates confidence in your system so that people don't have to go spend time second guessing and be able to trust the system. The replenishments are how you manage the changes. So those replenishments, again, are the purchase releases that you send to your suppliers based on the recommendations that MRP provides, and also creating manufacturing jobs so that you can produce the parts and have them ready for the customer as he needs them. So there's different kinds of requirements because somebody wants your stuff. Now, we talked about independent demand, which is the master schedule, and that comes from forecasts. It could also come from real hard customer orders that are firm, and we also have master scheduled items. Now, a master scheduled item isn't necessarily something you sell to your customer, but it may be a part that has a long lead time or has some difficulty in managing it in some way, and you want to put that as a forecast for maybe a purchase part. So a master scheduled item is going to have some independent demand that says, you know what, I need to buy some of these in anticipation of my customers' orders, and I want to have something to tell me that I want to buy 100 of these things every week. And so that could become a master scheduled item as a purchase part. So the independent demand isn't necessarily always going to be for finished good parts. Now, dependent demand is your component requirements. And we're going to talk about that. So this would be your purchased items generally, and sometimes your sub-assemblies are going to be dependent because they will be driven from an independent demand that says, my customer wants this, I'll create my job, and that job is dependent on that customer order. And some of the ways you can manage that is with a low-level code, and the component requirement, dependent demand, is always going to be greater than 0 on the low-level code. So we can talk about low-level codes, and it's just a way of envisioning and managing where your components fall in the bill of material structure. So low-level code is always 0 for a finished good item. The parts that make that up, which can include a sub-assembly and components, A and B in this case, are considered low-level code 1 because they go directly into the finished good at 0. So if we look at sub-assembly C, it has a low-level, its components are low-level code 2, and component D and E and sub-assembly F are the components that go into the sub-assembly C and its job. Further down, sub-assembly F has components, and they are at low-level code 3. So if we look at this a little bit, hopefully the colors will come through. We can see that component A and E are in multiple places with multiple low-level codes. So when we look at it, we would call component A and E having a low-level code of 3 because that is the lowest level that it's found in any bill of material structure. Not all systems use that coding method, but it certainly can be a benefit in being efficient to know where your process should focus, and you want to be able to make sure that you get clear down to the bottom, essentially low level 3, so that you can capture all the demand for your components. Let's talk about inventory, which is your stuff. So that is all the items that are purchased and or manufactured for resale. So it could include raw materials like just raw steel that you buy and sell. It could be a component item that might be nuts and bolts and other components that are produced and or purchased and then added into something else. It could be a subassembly that is a group of parts that goes into something higher. And then, of course, your finished goods, the things that you sell to your customers directly. Replenishments are the vehicles to be able to get new stuff. So we might have shop orders that would be, maybe if you think of it as a job shop, it's kind of a one-time effort. It may not be repeated. Some people distinguish between shop orders and production orders. A production order might be something that's repeated and it's an ongoing process in your company. So essentially they're both jobs that get processed through your production area. Again, purchase orders are the replenishments to buy that material. We also might have outside processing. If you have something gets heat treated, that you've produced a particular product and it needs to get heat treated, that heat treating may go to an outside supplier for that process, and you need to be able to track where it is in the process and who has it. So that would also be part of your replenishment process, those outside orders. So some of the output that you can get from MRP, and we talked about the action reports, they would be exceptions. So exceptions might be, do I have an order that's already out there that's now late? It might be that I don't have enough on order. I may have too much. So some exception that you want to be able to track and act on because it's out of the ordinary. Your standard material requirement report that says, here's what I suggest you do. We've got plenty of lead time, so you can make sure that you get this on order and have it delivered correctly. It might be planned orders, again, your shop orders that say, okay, I need to be able to create a job and have it out on the floor in enough time for the manufacturing people to produce it and complete it before I need to ship it. Purchasing requirements, the same idea. We need to create your purchase orders. And then we have pegging report. That is something that is sometimes important. It might the pegging is the idea of taking a customer and creating a job specifically for that customer's order, and then buying material specifically to fill that customer's job. It's not always used, but it is a very job shop kind of process, so that you know exactly what you've purchased and it is in-house and ready to be used for that customer's requirement. You also have the ability to do what-if reports that says, well, what if we bought these 10,000 widgets and we brought them in a month early? What would that do? It might tax our cash flow. It might hurt our inventory plan. It might actually solve the biggest problem of all. We can actually fulfill our customer's requirement. So the what-if reporting is a value. The last one, the net change report, that's probably not used anymore because computer time is really cheap now. And back in the olden days, there was a time when you had to buy computer time from a university or a large business because not everybody owned a computer, and the computers were big as a house. And so you need to be very efficient in using that computer time to calculate your MRP. I certainly had experience where MRP would run a full process over the weekend, and it might take 10 to 14 hours of computer time to get through our process. So you couldn't do that every day. So we planned to do a full run over the weekend, and then on one day of the week, Wednesday, Tuesday, Wednesday, something like that, we would run a net change MRP, and the only things that got calculated were changes in inventory quantity or a job that was opened or closed or some customer demand changed. And so it let the MRP run for maybe 4 or 5 hours instead of 14. So again, that's probably not something you're going to hear about anymore, but that was a reality just a few years ago, is that we had to do that kind of calculation to be efficient in our MRP processing. Okay, so here is the spreadsheet that I used to help run the company for purchasing and job creation just a few years ago. We had an ERP system that didn't have the kind of MRP calculation program that we wanted, and so my boss said, you go build us a spreadsheet that will work. So I had to go make sure I used all the calculations that were appropriate and be able to use all the same logic that some computer-based program would use to calculate MRP and come up with action items. So we are going to go on a field trip. It's a short trip. Okay, so here's our field trip. This is the spreadsheet that I built, and it's got a number of tabs along the bottom. And the first one is the master schedule. And so this represented our time-phased requirements that we wanted to be able to produce. So we had a number of finished good part numbers that all were based on a subassembly that was common. So that would be our basis of how we did our master schedule. We actually master scheduled against a subassembly that was common and drove it based on that batch of product. So these numbers here are representing the batch quantities of the product as a subassembly, which then we could, divide up and produce, 15 or 20 finished products with that same batch of common material. So 2 batches a week for a while, and then we skip 1, and then we jump up to 4 batches in this week, and back to 2, and none, and 2, and 2, and 2, and so this is our schedule. And when it came right down to it, we may not want to do 6 batches in a week. We may pull one of these forward and have some of those batches in the week that we don't have any activity. So that would be our level loading process, so that we could see that visually and know where our capacity restraints were. So from the master schedule, our finished good product we had identified as this 900-122 part number, and the very top row is our calendared weeks that we had on the master schedule, and our our requirements are showing in here for our batches. So those same batches that we looked at previously are now reflected up here in the calendar, and these are the components along the far left side that make up that 900-122 product. Now, the thing that we want to see here is we've got some material. It says we've got 24,000 each equivalent of this product in-house, and we've also got a safety stock of 4 batches that we want to be able to have in ready. So if we do the math here, it says we got 24,000 minus 4 batches worth. Then we'll come down here and it gives us, well, we'll have 13,000 some left, and we can then produce another 2 batches and we'll have 7,700 left. Another 2 batches, we're down to 2,000 something. Oh, we've got it. Now this one, we can't do all 2 of our batches. We're going to be short. And so it shows us that. So this would be my trigger to know I need to go put a purchase order for some quantity of this product. And so in my row here, I've got my planned stock. That's my calculation. And then I've got a scheduled receipt. I've got a PO line and a planned receipt. So it's telling me that I need to buy at least 3,576 pieces to fulfill my order here. So in my calculations, I knew that I had to bring this in to our building a week before it was needed so that we could process it through receiving and all the inspections that it needed. So I would plan my receipt in the week before. And so if I said, all right, I need at least 3,576, I might raise that to 5,000 to make it round. And I would put that on PO 1234. So that would be my note that I've actually placed that order with my supplier, and my calculation just got extended. So I can then produce my 2 and another 2, and then now I've got another shortage. So I could produce and say, okay, I better tell my supplier I need another 5,000 in the next week, and we're also going to put that on the same PO because we'll just extend it with that. But that's how we would be able to know what that calculation requirement was, is that whenever I took its suggestion and firmly placed a purchase order, it would recalculate that row and say, where do you need that product now? So I could skip a week and say, gee, I need 10,000 now. So maybe my next order is for, let's make it 15,000. And we are able to have another batch of product that we can produce. So again, our purchasing is real time. It gives us real active interaction about what we need to do in our purchasing and essentially creating jobs to fulfill our customers' requirements. So how we get this number, we looked at this 24,000. This is our inventory accuracy. So it's got its own little tab right here, 600-101. There's my 600-101. This is my inventory record. And it says that I purchased 50,000 units on PO 7780 on, that was an old one, February 28, 1997. So, but then I opened my jobs and it was reduced by the correct amount until that particular product was at 0. Now this one, I still have 1,290 pieces from this purchase. It hasn't been completely consumed. And this one has 13,000 pieces, and this one has 9,999 pieces, which total up to this 24,000. So again, all manually entered and taken from information of reports back to me that I would be able to keep my inventory accurate so that I knew that I could purchase in confidence and have the right product here when we needed it. If we jump down here one more step, this is my subassembly. This is the batch of product that is common among all the finished goods. And it has its own set of components, and it is acting the same way. It's taking its information from the master schedule. Those same weeks are represented with the quantities. And again, the same idea is that I'm purchasing components for this, and I would be able to say, gee, I need to have another receipt from my supplier, and if I bring 150 in, then it pushes my shortage out into the future, and I have product available right here to build my next set of components into my product. So I think that would end our field trip for now. Back to our presentation. So our exception reports that we talked about, and we saw some of that information on my spreadsheet, is that it could tell us if it was in here too early, or if it was in here too late, or we didn't have enough, or in some cases we just bought too much and we didn't need it at all, or gee, we need it now, we have to expedite this receipt and job. So those are the kind of the exception reports you should be able to expect from your MRP output. So the material requirements, kind of a summary here, is a report that is time phased. Again, we had a calendar across the top against our current inventory and any scheduled receipts, and then recommends planned orders to be able to produce that product and have a date and a quantity that relates to that requirement. So if we're talking about purchase orders, again, time phased, it needs to be very quantity specific. We need to know what supplier or vendor we're going to buy it from and what items that we need to have purchased from that supplier. And our shop orders, we need to, again, time phase those so that we know what date, what items, what operation we're going to use that product in, and how much we need to produce to be able to produce our product. Kind of a summary, we talked about each one of these pegging reports. That could also be known as allocation. Some of the other computer systems might have that as an allocation process. What if, net change, again, kind of an obsolete idea. How many days available do I have in my product? If I've purchased this material, how many days will that last me? So that's another report that you might find in your MRP output. How much inventory do I have that's old or slow moving? you'll want to find out that because it costs you dollars to hold inventory that you're not using. And then how much, if I actually have this material on order from my suppliers, what is my projected value of that inventory into the future? So those are some of the other reports that you'd be able to capture based on information contained in MRP logic. Okay, now we're going to move to manufacturing your stuff. And we're going to use all the tools that we've talked about here. So the stuff in your toolbox, we've got a bill of materials, we've got standard routings, we would have shop floor jobs or shop floor control. We can also touch on manufacturing cost accounting and standard costing. So our bill of materials is the stuff of which your stuff is made. But really, it's a structured listing of all the inventory items required to complete your stuff. And it might include raw material, any components, and sub-assemblies. So again, we saw our indented bill of material. We saw how that worked. And that, again, we're looking at low-level codes, kind of just a review. This is a different view of it, same idea. We've got our finished product at the top. We're building a dune buggy. And we've got our sequence number 10 there, a DBFA, which is a dune buggy front axle. We need one of those. And a dune buggy rear axle, we need one of those, and a frame, and a spoiler, because that's important. But our front axle, we need two components to build those. So we need two wheels to build a front axle and a front axle assembly. So again, same thing with the rear wheels. We need two rear wheels and a rear axle to make our rear axle assembly. So that's a different visually way to depict your bill of materials. So the standard product routings is how your stuff is made, and that is a list or a bill of labor in which you are able to structure all of the steps and the stages and operations, and including the work centers that you might need to complete your product. So here's a standard product, very simple. First step is we do our initial assembly, and we call that operation 10. Then we take what that output from there, and we go weld it, and that's operation 20. Now our paint prep, we need to make sure that all that stuff's ground down and ready for the paint shop. So we're going to do that work on operation 30. Then we're going to go paint it in operation 40. And then we're going to put our final assembly together on operation 50, and we're going to have the inspectors look at it and say, yes, you did it right for operation 60. So now what we need to do is combine our bill of material and our standard product routing in the combination, which becomes a shop floor job, and that's how you build your stuff. So here's an example of that. So operation 10, we're going to take two of component A and one of component B and put those together in our assembly. Then we're going to take that, which is subassembly C, the results of op 10 is subassembly C. We're going to take one of those and weld it to component D, and we're going to put two of those guys on it in operation 20. Then we're going to go to paint prep, and we don't have any material requirements there because we're going to just grind it up and sand it down. Then we're going to go paint it in operation 40, and our final assembly says we're going to take subassembly F, which is the painted part, and we're going to have one of those, and we're going to combine it with a component A, and then we're going to send it to the inspectors. So each one of those operations that have a bill of material requirement are part of that time-phased process, because if this whole process takes you 2 weeks, then you need to know that component A and B have to be here 2 weeks before you're done, but component A and assembly F may not be required until the last day of your process, which makes a difference in who's buying and when they get delivered. So that time phasing is important even within a job. So cost accounting, that is where you link your shop floor control or the combined bill of material and routing when you're able to track your estimated standard against what the actually costs to build your product. So that's where we do, what's your stuff worth? You're able to combine the standard costs for the material and product routings and then roll that in to become the standard cost, which becomes your comparison to actual, and that's carried in the item master. So we're done for this.
Okay.
Turn the time back over to Cindy.
All right, well, thanks, Tom. If you have any questions to submit, please do so at this time. I did get a few questions while you were talking, though, so let me just ask you, I'll let you know what they are. First of all, someone asked, we have a minimum purchase quantities from some of our suppliers. How does that work with MRP? Well,
that's a very common field, actually, in a standard MRP program. You would be able to say, what is my standard order quantity? Otherwise, if you're doing it in a spreadsheet, you just need to make sure that you've accounted for a field that says, this supplier requires that I buy 10 cases of something, and just make sure that that's included in your calculation, and then you'll get the right results.
I saw that you listed the operations with a numbering sequence, 10, 20, 30. Why didn't you just use 1, 2, 3?
Well, some of that comes from programming language, and it's also a very convenient way to insert additional lines in your bill of material and routing. Because if you said, oh, I've got 1, 2, 3, and now you said, oh, I need to put one more in here, I have to go renumber all of my routing lines. And so I could then easily, if I do 10, 20, 30, I can insert 15 and 25 and whatever I need to very easily and not disrupt the rest of the process.
Another question, how do we get our inventory accuracy up to a minimum 70%?
That is a tough deal, but it's doable. Certainly there's some factors that you need to consider within your company. You'd need to make sure that your operators and people like material handlers are trained to do transactions as they need to be done so that you know where it is and when it's been used and when it's been received, so that inventory is correct as they process it. You also need to make sure that your bill of materials are correct on your parts, because if you've said, well, I think, or the bill of material says I use component A and there's supposed to be 3 of them there, and the guy out on the floor says, well, that doesn't work, it's too long, I'm going to put this other one in there and I only use 2, then you're always going to be short of the one he actually used and way overstocked on the 2 that are supposed to go in there. So you need to make sure that what's being used is the same as what your bill of materials list says. So that's important. But one of the biggest things is, once you've kind of got those pieces nailed down, you want to be able to have what's called cycle counting. And so you systematically go through all your inventory and count it throughout the year. And if you do that consistently, we have found in many of the companies that I've worked for and worked with that there's no requirement by any of the accounting auditors to do a full annual inventory anymore, which makes life much easier, because my experience is anytime you do an annual physical inventory, you actually introduce as many errors as you correct. So you come out no better off, you just have different numbers. So cycle counting will help this process, and it's smaller buckets of data you're trying to process, and you do it consistently throughout the year, and that in itself will help you increase to the 98% that you want to get to.
I think that is all of the questions that we have. If anyone does have further questions in the next few days or ever, please feel free to reach out to Tom or to anyone on our manufacturing services team here at Revolution Group. Once again, I thank you, Tom, for presenting today, and I thank all of you for attending. Have a great day, everyone.